So last year in pre-cal, I actually gave you, I think, this exact same slide.
Yeah.
And I said, what is calculus? And I told you calculus is the math of change. If you want to make it more exciting, technically, it's the math of changing change.
Oh.
Cool. Changing change. What do I mean by changing change?
Change that change.
Yeah?
Yeah.
Maybe go. Does a line change?
Yes.
What changes with a line?
Its position on a graph.
Its position, its direction,
Yeah, but once you're in a line, its direction doesn't change, right? Once you're in a line,
Its length.
its length, kind of. You can go from one point to the next, to the next, to the next. That's true. And as you go from one point to the next, to the next, to the next, how do you change from one point to the next?
slope.
Slope. Rise over run, right? So if you're at a point, how do you get to another point? Rise, run. To another point, rise, run. To another point, rise, run. What is true about the ratios of the rise and the run for any line? They are
It's
all
constant.
the same. Good. They're all constant. They're all the same. The change, how it changes, doesn't change. Do you guys remember from pre-cal?
X squared.
What? That's something from pre-cal. No. From pre-cal. Do you remember how we would find the rate of change for a problem?
Table.
Hurt.
You could.
Okay.
Hurt does change, but in a calculus way, so that's kind of confusing. But it does have a rate, right? P times E to the RT. There's a rate, but it's not quite as basic as what I'm looking for.
Y2 minus Y1 over X.
Yeah, slope. Slope found us rate of change. Okay. So, do lines change? Yes. Do lines change at a rate? Yes, but at a constant rate because the slope is always constant. If I was to ask you what kinds of graphs have slopes, what would you answer? What kinds of functions, what kinds of graphs have slopes? I heard all of them, and I heard y equals mx plus b.
Yeah.
What do you guys think?
Y equals mx plus b.
Has a slope.
Yes.
So does that mean that PK was wrong?
That was Tyler.
Oh, you said it. Good job. No, most kids, if I ask them what kinds of functions or what kinds of equations have slope, they're like, lines. Why? Because that's what you did in Algebra 1. Slope is rise over run, y2 minus y1 over x2 minus x1. But what about last year when we did slopes to quadratics? Remember that one?
Yeah.
We had to use the focus
Oh.
and geometry and the distance formula. It was your favorite section ever because, no it wasn't, you hated it, because we had to do this little thing to find the slope of the tangent line, which we visualized by taking a pen or pencil and hitting the graph and skimming it. To find the slope of the tangent line, we had to do this cool thing from the focus and find like a D and then go down like another distance, D, and then those were supposed to be congruent if I drew it perfectly, which I didn't. And then you could find the slope between those 2 points and have your tangent line. And it was so rough and hard, right? Don't you guys have in your groups, don't you have a quadratic on a cool little whiteboard? And doesn't that quadratic have a point that's marked at the point 1, 1?
Yeah.
Can you guys take a straight edge, either a pen or a pencil, or the edge of your composition book, and can one person in your group take an edge up next to that point and try to sketch for me a tangent line with your marker? Sketch for me the tangent line that would hit y equals x squared at the point 1, 1. You can take your composition book as a straight edge and like skim the graph. You can take with your ID card or a ruler if you have a ruler. So try to sketch for me and for your group the tangent line that goes through the point 1, 1. Never mind. I see the ID card. Is it up there? Oh. You have old ID cards.
Yeah, unless you say.
Credit cards? Who is it? Credit cards?
Just kidding.
Wait, so.
You can take your. Just imagine that it's coming up against it and skimming it. Ooh, can I use yours? shoop, shoop, tangent lines-ish, right? Now you can extend it if you want. You can extend it until it hits the axis. My question would be for you, when you have your tangent line, what is the slope? Do you know the point 1, 1?
Yes.
Yes, but what do you not know besides that?
The M.
The second point.
The second point. Every slope needs 2 points. Now, does this hit the axis somewhere?
Yes.
But do you know exactly where?
No. But you can calculate.
But how? We're not going to be doing foci today.
Oh.
We're not going to be doing distance formulas today. We're going to figure it out another way. The first big question of calculus is, well, first of all, not only lines have slopes, not only lines change. There are other graphs that have change, that changes, aka slopes that are always changing, rates that are always changing, and that's what calculus helps us find. I did more stuff last year, but for right now, let's just go to tangent line problem. What you have just done is take a quadratic, taken a point. Now, ours is way zoomed in. This is way zoomed out. But taken a point like 1, 1 and sketched a tangent line. And I've asked you, what is that slope? And you're all like, because you only have 1 point, and up to this point, without using a focus in geometry, you've needed 2 points to find the slope. True?
Yeah.
So in your groups, well, I guess I could show you one more slide. Let me freeze the screen. I'm going to show you one more thing before I have you guys get going on exploration. One of the big problems calculus graphically tries to solve is the tangent line problem. How do you find the slope of a tangent line? Because all functions have slopes, not just lines. But lines were the easiest slopes to find because they're always the same. So how do you do slopes of other functions? How do you do rates of change of other functions? With pre-cal. With pre-cal, let me turn off the other light. This exposure is really bad. Projector. With pre-cal, we can't do a tangent line. Or I should say pre-cal, before calculus, before any of the calculus ideas, besides the focus and the distance formulas for quadratics only. But if we were talking about all different functions, all different tangent lines, the focus trick doesn't work. So before calculus, we can't do tangent lines, but we can do what we call secant lines. We couldn't do a tangent line, but we could do a secant line. Now, if I was to not skim here, but instead cut through the graph there, guys, would the lines be the exact same?
Yeah. No.
If I was to cut through the graph instead of skimming, they'd be different, right? So this one doesn't give me my answer, but it does give me an idea. So with pre-cal, okay, we could have done a slope m by doing a y2 minus y1 over x2 minus x1. And more specifically, if we're talking like a particular tangent point, we wouldn't just make it any y1, x1, we would actually use the tangent point. So in your picture, didn't I say that you guys had the point 1, 1?
Yeah.
So we could call that point of tangency by a special name, like, hey, it's at x equals c, and then the function value or the y value there, f of c. And then if we wanted to, we could actually like redefine the other point, but for right now I'll just say, okay, some other point could be used with that tangent point, and we could get a slope, but it wouldn't be perfect. It would be what we would call a secant slope, or the slope of a secant line. So how do we use that in order to get the slope of a tangent line? That's the question that we're trying to solve. That's the question that we're trying to figure out. If we can find the slope of a secant line, and a secant line is not a tangent line, how do we use secant lines to get tangent lines? To that end, boop, boop, here's what I want you guys to do with your group exploration.
But we need to copy that down.
Kind of, but not all the words. Ready? So underneath, you're in the tangent line problem, right? You can go ahead and just put exploration, and here's the givens. But you don't actually need to write all of these words. You do need to say exploration, and then our function is f of x equals x squared, which is exactly what's on your paper. And then I want you to make a table. And with that table, I want you to do or show the points that you're using and the slope that you find using the formula y2 minus, well, hold on. What's the point that we're trying to find the slope at again, guys, for the graph on your paper? What point?
1, 1.
Yeah, 1, 1, right? So we're going to do y2 minus f of c all over x minus c. But what we get to do for every single one is we're going to use the point 1, 1 for every single example. Because we're making secant lines. I'm going to give you guys a chance to read this. But we're making secant lines, and every single time we're going to the point 1, 1. So I think 1, 2, 3, 4, 5. They give us 5 different points. Whoever has the marker. Once you have the table set up, I want you to find for me all the different x values that are in each of these different points. So the Q1, Q2, those are just the names. Don't stress about those too much. But I want you to mark on your x-axis all the different x values. So for instance, there's x equals 1. We already have that marked. But then it says x equals 0.4. So that's like 0.5 minus a little bit, right, guys?
Yep.
0.99. Oh, man, that's like right there. True? 1.1. Okay, that's maybe a little bit away. 1.01. Oh, stink. That's like right there. 1.001? Okay. Just try to get little tick marks for 0.4 on your blue paper. Somebody with the marker. Where's the 0.4? Where's the 0.99? Where's the 1.1? Where's the 1.01? Where's the 1.001? It's going to be hard. Just kind of try to show it getting closer. Oh. Getting closer from below or from the left and getting closer from above or from the right. Sounds kind of like limit. What's this nasty mathematical term for getting closer?
Approach.
You don't put out the words, but get the table. Get the exploration and the sketch and the table in your notes. You don't have to write all the words. Just as best you can. 0.4-ish, 0.99-ish, 1.1-ish, 1.01-ish, 1.001. As best you can. I know. And do you still have your straight edge? If so, can you mark the point at 0.4? And can you draw a secant line between 0.4 and 1? And you should already have that tangent line just kind of chilling, being like, I don't know who you are. I wonder what you are. It's a big question we're trying to figure out today. You have your tangent line. That's the one we're trying to figure out. But then we have this 0.4 that you can draw a line between the 0.4 and the f of 0.4 and the 1, 1. Guys, this guy has 2 points. How could we find the slope if we were going from 0.4? What's the y value if x is 0.4? What's the y value if x is 0.4? This says f of 0.4. because Joe said, oh, it's x squared. Can't I just plug it in, and say 0.4 squared is the y value? 0.4 is the x value. 0.4 squared, plugging it into x squared is the y value. Can I find the slope between these 2 points?
Yes.
Yeah.
You
How?
need 2 points.
Yeah, I need 2
Plug in
points. We just
formula.
plug in the formula. So y2 is my 0.4 squared. It's the extra point I'm taking. And aren't we just going to use the 0.11 every time? Getting your calculator out might be a really good idea. So we're finding the slope between the 0.4 and the 0.4 squared and the 0.11. It's not the tangent line, but we're figuring out who he is anyway. Has anybody got me a number for this yet? 0.4 squared minus 1 all over 0.4 minus 1. If you're putting it in your calculator, not using the cool fraction button, don't you have to use parentheses, numerator, parentheses, denominator?
1.4.
I think so. Anybody else get 1.4? We're still looking for calculators. I remember that from period 1. It was a good sign. Just a hint though, your group's going to be let go in about 2 seconds to finish this whole table. Somebody needs to find a calculator. Or I have the little baby ones up there. Oh, there you go. Hi there. So guys, let me get down the other points. I want you to get 0.4 and then the 0.991.
Oh.
And then the 1.00011. And then the 1.011. And then the 1.11. Can you guys find me the slopes between each of those? And as you do, can you try to sketch as best you can? Going up to the curve, hitting it, and then trying to sketch the line? Try to sketch the lines too. You have all of your different points. I want to know the slopes. Huh. Even just between 0.4 and 0.99, man, it sure seems like those secant lines are converging towards the tangent line. Converging, that's a thing. I see people plugging in the points. I see people setting up their slope formulas. I see a calculator person trying to plug and chug. Check in with each other and make sure we know what we're doing. Finish the table. Do you know how? Finish the table. Do you know how? Somebody's excited outside.
I don't know if that's right the second fraction only has 2 zeros and 7. The 0.99 is 1. Yeah, I only put for the second one. And then for the 1.000, I have 2.00. That's 2.0001.
1.0.
1.999. Maybe this one is 1.4.
3 just do 0.
But I only have one. Okay, I'll do it.
Double check my math real fast. I just pulled it out of what I remembered from this morning. Is that good?
Yeah. Yeah. Just use it.
What do you see as the x's get closer to 1 from below 0.4, 0.99, or from above 1.1, 1.01, 1.001? It's like limits we're approaching. What's happening to the slopes?
It's increasing.
Getting closer and closer to who or what?
To the value.
So guess what the slope of the tangent
2.
is. Does anybody remember from last year what the slope of the tangent? There's a really snazzy term. It was in your summer packet. The slope of the tangent line is the exact same thing as the word. It was the bonus on your summer review. Derivative.
Derivative.
Did we learn on the summer review packet how to take a derivative of x squared? What is f prime of x squared? 2x. Where are we trying to find the derivative or the slope of the tangent line at? X equals? Could we have found this just by using the power rule? We can use it with secant lines, or we can also use it with tangent lines. With calculus. With calculus, we can answer how to do the slope of the tangent line with limits of secant lines. Kiddos, nice thing is, I already extended the homework in period 1 to be due on Thursday. I will change it in your Google Classroom right now.
Thank you very much.
So your goal tonight is to start as best you can, but you might not get very far. Tomorrow we will definitely get into our books and see what's going on with the homework. Bye, guys. Bye. Bye. Erase, put back, and get out of here. I'll see you guys later. Bye.
Yeah.